So what is a PVST Plus or Rapid PVST Plus Extended Bridge ID? Now, spanning tree requires that every switch have a unique bridge ID. In the past, this simply consisted of the bridge priority and MAC address. So bridge ID consists of 8 bytes, with 2 bytes being the bridge priority and 6 bytes being the MAC address. However, when configuring multiple VLANs and running per VLAN spanning tree, a different MAC address would have to be allocated for every VLAN. PVST creates an instance on a per VLAN basis. So to ensure that the bridge ID is unique on a per VLAN basis, a different MAC address would have to be allocated. Now that works fine if you only have a few VLANs, but if you're configuring hundreds or thousands of VLANs, it's not scalable. If a vendor was supporting PVST, the vendor would need to assign a unique MAC address on a per VLAN basis. So in theory, if 4094 VLANs were supported on a switch, 4094 unique MAC addresses would need to be assigned to every switch. That's simply not scalable. So to conserve MAC addresses, this system was changed, and an extended system ID is also known as MAC address reduction. So with extended bridge IDs, the bridge ID is still 8 bytes in size, but the priority is now split into 2 parts. So the 2-byte priority portion consists of a 4-bit bridge priority and a 12-bit extended system ID. The MAC address is still 6 bytes in size. So please note, bridge priority is 4 bits, extended system ID is 12 bits, which equates to 2 bytes. The extended system ID is populated with the VLAN number, and the bridge priority is a value that you can set. Default is 32768 in decimal. In the past, the bridge priority consisted of 2 bytes, and you could set the priority to a value such as 1. However, that's no longer supported. On a switch, as an example, if I type spanning tree VLAN 1 priority and try and set it to 1, I'm told that I need to set it in increments of 4096. So the values allowed are one of these. The reason for that is that the bridge priority has been split into 2 portions, with only the most significant 4 bits being available for the priority. So if you set the bridge priority portion, the 4 bits, to binary 1, and you take the full 2 bytes into account, that would equate to 4096 in decimal. So if the priority bit is set to 1, the extended bridge ID priority works out to 4096 if you take into account the full 2 bytes. If you set the bridge priority portion to 2, so 0010 in binary, and look at the full 16 bits or 2 bytes, it equates to 8192 in decimal. On some vendors' equipment, you can set the priority to 1 and it will automatically be converted to 8192, but on Cisco switches you need to set the bridge priority in multiples of 4096. So once again, if I try and set the priority to 1, it's not allowed. Set it to 4096, that's allowed. Do show spanning tree. Notice the priority of this switch, because it's running PVST Plus, is 4097, so the priority plus the VLAN number. If you were looking at VLAN 10 as an example, the priority would be 4096 plus 10. If you're looking at VLAN 20, it would be 4096 plus 20. I'll demonstrate that in a separate video.